This is week 7's interactive advanced concept presentation. So I have some oil here, bottle of ink, which I've already poured out in this bowl, and some rare earth magnets. So the idea of a ferrofluid is that, in this case, in the ink, there should be nanoparticles that are either iron or magnetite. When these are exposed to a magnetic field, because of unpaired electrons within either the iron or the magnetite, they are attracted to the rare earth magnets. So the strength of the magnets is determined by electron spin within these unpaired electrons. So in order for this spiking to happen with this fluid, the spin of the unpaired electrons within the metallic particles in this liquid has to line up exactly with the spin of the unpaired electrons and the magnets. So if those don't line up, it's not going to work. Or if, there are not enough unpaired electrons, it may not work. So I did some research on this ink because there was absolutely nothing on the bottle or on the box that told me exactly what was in it. It was the only bottle of ink that I could find. What I found was that the ink may be suspended in water. It may be suspended in an ethylene glycol, or it may be suspended in an oil. So first I thought I would try to expose these particles to a magnet without adding any oil, because it may already be oil. It may not need more oil, but if it doesn't work, we'll add some oil and see if, with some added surface tension, if we get any response. Okay, so with one, that up a little, there's absolutely no pull going on with that. So this liquid actually looks oily, but we'll add a little bit in and see if it makes any difference at all. You can see the oil is pooling kind of in just a little circle on the top. There are just tiny little bubbles that form. There's almost nothing going on there, but there are little teeny tiny bubbles. I don't know if it's visible at all on the camera, but nothing really extreme. I will say the longer I hold that magnet there, the more bubbles there are, and they do move a little bit, but they really don't look like spikes. They truly just look like little bubbles. So in my research on this ink, I also found that it's actually not iron or magnetite nanoparticles in there. It is titanium. So knowing that titanium only has 2 unpaired electrons, as opposed to iron, which has 4 unpaired electrons, and magnetite, which has 5, I would expect this to not work real well. There's just not enough unpaired electrons to make any kind of really exaggerated response to a magnetic field. So, had it actually contained more magnetic metals, then it makes sense that it would create a very spiky appearance and make this liquid look more like a solid temporarily while it was being influenced by that magnetic field. Well, that's it. Thank you.